In the Clean Aviation project, FASTER-H2, DLR, together with the partners Airbus, NLR and ONERA, successfully developed and manufactured crashworthy hydrogen storage solutions for future aircraft. DLR's focus in this project was on innovative manufacturing technologies and the use of thermoplastic composite materials. Based on extensive simulations, we developed a hydrogen tank integration design and built a demonstrator for transient dynamic structural tests. Thermoplastic components were manufactured using our state-of-the-art thermoforming facilities. This resulted in an efficient production process with a high standard of part quality. With high precision and optimized cycle times of just 5 to 6 minutes per component, this is a good example of cost-effective manufacturing. After thermoforming and trimming, we use resistance welding to integrate L-clips on the intercostals. This method removes the need for adhesives or fasteners, enabling a faster, more efficient production of strong, lightweight composite parts. Process cycles of 2 minutes per weld at a target temperature of 380 degrees Celsius were achieved. Water-coupled ultrasonic inspection indicated a defect-free interface and confirmed flawless welding quality. Next, the intercostals were integrated at the facilities of NLR by induction welding. This process is contactless and does not require any additional materials at the weld interface. During welding, pressures of up to 8 bar are applied at the target temperature of 360 degrees Celsius during a process time of around 5 minutes. Manual and ultrasonic inspection proved a high-quality joint between the intercostals and skin. After assembly, the demonstrator was analyzed using our advanced optical 3D measurement system. The data was converted into digital 3D models, providing valuable input for manufacturing simulations. Additionally, the data was used during manufacturing to analyze deviations and optimize the production processes. The tank mount was designed with crashworthiness features. A specific strut attachment was developed to serve as a load limiter, ensuring the structural integrity of the tank in the event of a crash landing. Using the high mass-specific energy absorption of carbon composites, the concept was validated at DLR through high-speed testing and full-scale crash simulations. The tests confirmed the design concept and demonstrated the intended load-limiting crash function. This project is pioneering the integration of hydrogen fuel systems into aircraft, overcoming key engineering challenges for zero-emission flight. Our end-to-end process, from simulation and design to manufacturing and testing, has laid a transformative foundation for a more sustainable future for air travel.